let's do another example. Okay. Suppose we have a variable x which is normally distributed with a mean of 9 and a standard deviation of 1. Okay. Let's say we want samples of size 16. Okay. We want to know the distribution of sample means of size 16. Okay. So what the question is asking us is asking for the sampling distribution of sample means of size 16. Okay. So again, we need to identify three things. First off, the expected value of all the means is equal to the mean of the underlying variable x, which is equal to 9. Okay. Second, the standard error of the mean is equal to the standard deviation of the underlying variable divided by the square root of the sample size. So in this case, this is going to be equal to 1 over the square root of 16, which is 1 over 4, which is 0.25. Okay. Third, we want to determine the distribution shape. Okay. Here we know that x bar is normally distributed because the original variable x is normally distributed. Okay. In other words, sample means of size 16 are normally distributed with mu x bar equals 9 and sigma x bar equals 0.25. Okay. So all I did here was applying the theory we learned earlier. Okay. So let's do a follow-up question. Let's find the probability that x is greater than 11. Okay. Now, for this type of question, you want to first identify what you're being asked. Okay. So here we're being asked for the probability that x is greater than 11. So we're being asked about the variable x. Okay. Now remember that x is normally distributed with a mean of 9 and a standard deviation of 1. Okay. So we know then that x is not standard normal. So if x is not standard normal, the first thing you want to do is you want to standardize it, right? That's what we've always done. So the probability that x is greater than 11, you want to standardize, right? So this becomes the probability that x minus mu x divided by sigma x greater than 11 minus mu x divided by sigma x. Okay, this becomes z. Here we know that the mean of x is 9 and the standard deviation of x is 1. In other words, this is 11 minus 9 divided by 1, which is the probability that z is greater than 2. Okay, so now this is in the form where the probability that z is greater than something. So in order to use a table, we need to flip the inequality sign, right? So this is equal to 1 minus the probability that z is less than or equal to 2. Now you can go to the table, look for 2, and get the probability. Okay, so let's go to the table. You want to look for row 2.0 and look under column 0.00, right, to get the probability of 0.9772. Okay, doing the calculation gives you 0.0228 as the answer. So the probability that x is greater than 11 is equal to 0.0228. Okay? Now let's do another follow-up question. Suppose we want to find the probability that x bar is greater than 11. Okay? Now recall that x bar is normal with mu x bar equals 9, right? And sigma x bar equals 0.25. Okay? Again, we observe that x bar is not standard normal. Okay? If it's not standard normal, to find the probability that x bar is greater than or equal to is greater than 11, the first thing you want to do is you want to standardize. Okay. We standardize by subtracting the mean and divided by the standard deviation. We do that for x bar and we also do that for 11. Okay. Again, this becomes z. We know that mu x bar is equal to 9 and sigma x bar is 0.25, right? So 11 minus 9 divided by 0.25. So we turns out it's a probability that z is greater than 8. Okay, now we want to flip the inequality sign, so you want to go to 1 minus p, 1 minus the probability of z less than or equal to 8. Now we go to the table and look for 8, right? If you go to the table, you're going to notice that the table ends at 3.49, right? That's the largest value on the table. So how do we figure out what 8 is? Okay, so let's go back. Let's draw the normal distribution. Okay, so let's say that's your normal distribution. We know the table goes all the way to, let's say this is 3.49, and we know that the area to the left of 3.49 is 0.9998. This is from the table, right? Okay. So if we move to the right of 3.49, this probability is going to be larger and larger, right? So the rule is whenever we go past 3.49, we're going to treat that probability as 1. Okay, in other words, the probability that z is less than or equal to 8 is going to be 1, and so this is going to be 0. Okay, so the purpose of this exercise is for you to realize that you have to be really careful about what you're being asked for, right? In the previous example, you were asked for the probability that x is greater than 11, right? Specifically, you're being asked about x, so you want to standardize using the mean of x and the standard deviation of x. In this problem, you're being asked for the probability that x bar is greater than 11. Okay, so the variable of interest here is x bar. Okay, and so because you're being asked about x bar, you want to standardize using the mean of x bar and the standard deviation of x bar. Okay, notice that these are two very different variables, and the answers you get are also very different. Okay.